Okay, thanks to everybody for the opportunity, and apologies for the technical problems. So this is joint work with Eleonora Broccado and Luigi Zingalis. And what we're interested in here is the role of firms in mitigating social harm. So in standard theory, firms maximize profit or market value, and the provision of public goods and charity is left to the government and individuals. But suppose that government isn't doing a good job of imposing Pigovian taxes, so they're not getting that right. In a previous paper with Luigi Zingalis, we argued that if investors and consumers are socially responsible, then they will want firms to act in a socially responsible manner. For example, with respect to the environment. But the question is, how can this be achieved in practice? So that's what this paper is about. So I'm going to develop a model, and in the model, some agents, some investors, some consumers are socially responsible. And by that, we mean the following: that when they make a decision, they put a positive weight on the welfare of other people affected by their decision. So they put some 100% weight on their own payoff, but then they also put some weight, less than 100%, on the payoff of others. So there are some people like that in the economy, and then there are regular, purely selfish investors and consumers. SR agents, so SR stands for socially responsible, they face two options. Echoing Hirschman here, they can exit, so investors can divest from polluting companies. So here we're going to be focusing on pollution, that's the environmental harm. They can refuse to invest in those companies. Consumers can refuse to buy their products, they can boycott them. So these are the exit options, or the other possibility is voice. Investors can engage with companies, with management, and try to change corporate behavior. And what we do in this paper is study which strategy is more effective. So we're going to compare the strategies. And let me say that here, when people divest or boycott, our assumption for this paper is going to be that they do it in order to have an effect, as opposed to for moral reasons. We're not saying those aren't important, but we're interested in people who are doing it to actually have an impact. Okay, there are large literatures to cite here. I don't have time to go through the papers, so let me just, I'm flashing them up here, and we discuss them more in the paper, which will be available very soon. Let me jump to the model. So it's a 3-date economy. Firms set up at date 0. Production decisions are made at date 1, and then there's a product market at date 2. Now, when firms are set up, we assume that the environment is not an issue. People don't, pollution, all this sort of stuff, climate change is not something that people are thinking about at that point. But it's going to come later. It's going to be a sort of an unexpected, an unpleasant surprise at date 1. There's a setup cost for each firm. Firms are going to be set up by profit maximizing entrepreneurs. Setup cost F. Once a firm is set up, it has a capacity constraint equal to 1. So 0 expected marginal cost up to the capacity constraint. The entrepreneurs who set up the firms are not personally wealthy, so they finance the F by selling shares to investors, and then they take the money and retire. It's going to be a perfectly competitive environment. The good which is traded in the product market at date 2 is homogeneous. There's a riskless rate of interest throughout, equal to 0. Okay, now I said the expected cost after you've set up, after you've paid the F, the expected cost of production, production occurs sometime after, between date 1 and date 2, is 0, but it's uncertain. The cost is uncertain, and we write it as epsilon. where epsilon is normally distributed with mean zero and variance sigma squared. And it's important here that epsilon is an aggregate shot. It hits all the firms. The reason for this is we want there to be limited risk capacity in this economy. So people cannot get rid of the epsilon by diversifying. Now, the profits of each firm are given by, remember, capacity constraint of 1, 0 marginal cost. So they're all going to be producing, the ones that set up are going to be producing at capacity. So they'll produce 1 unit, they'll sell it at the competitive price P, but their costs are epsilon. So their profit is P minus epsilon, which is a random variable. The expected value of that is P. Okay, now we have investors and consumers in this economy, as well as the firms. Investors and consumers are separate, right? Separate groups. I'm going to normalize the number of each to be 1. So there's going to be 1 consumer. You'll see later we're going to replicate the economy, but right now there's 1 consumer, and the consumer's utility function is given there, rho q minus half tau q squared, and then it's constant marginal money, constant marginal utility of money. So we then just subtract off the expenditure on the good, which is Q. They're buying Q units at price P, so PQ is how much they spent. Now, if you maximize that, you get a linear demand curve, and there it is, Q equals rho minus P over tau. So that's demand at date 2 at price P. Now, what's the supply? Well, if n firms set up at date 0 and they're each going to supply at their capacity constraint of 1, then the total supply is n. So at the bottom of the slide there, you see the condition for market equilibrium at date 2, and that gives us P equals rho minus tau n. And remember, pi, expected profit of each firm, is also P. So that's how we get the bottom equation. Now, so that's the date 2 market equilibrium, product market equilibrium. But now let's talk about the capital market equilibrium at date 0, where, remember, the firms, the entrepreneurs are financing the setup costs by selling shares to the investors, and I'm going to normalize the number of investors to be 1. Now, in a free entry equilibrium, which is what we're interested in here, the market value of each firm must be F, because if it was bigger than F, it would be profitable to set up more firms, and if it was less than F, then entrepreneurs would drop out. Okay, so V is going to equal F. Now, consider the investment decision of the investor. If the investor buys X units of shares, actually think of X as the number of firms. So X equals 0.1 means you're buying 10% of a firm. X equals 2 means you're buying 2 firms. So your return at date 2 is going to be X times pi tilde. There's randomness there. And you also have to buy the shares, and they cost F, so minus XF. And you can have the investor as borrowing to buy the shares, at the 0 riskless interest rate. And let's normalize the initial wealth of the investor to be 0. Now, the investor has an exponential utility, constant absolute risk aversion, with coefficient gamma. So we evaluate X pi tilde minus XF. The certainty equivalent of that is the mean, which is X times pi minus F, minus half gamma times the variance, and the variance is X squared sigma squared, because remember, pi tilde is P minus epsilon, and epsilon has variance sigma squared. So we get the formula for the certainty equivalent in the middle of the slide there, and the investor will choose X to maximize that, and that gives us X equals pi minus F over gamma sigma squared. That's the demand for shares, and the supply of shares is N, because if there are N firms that set up, then, each one is selling its shares to the public, and so the supply is N. So there we have the condition for market equilibrium, stock market equilibrium at date 0. But we also saw on the previous slide that pi equals rho minus tau n. So combining all that, we can solve for n. N equals rho minus f over gamma sigma squared plus tau. That is the free entry equilibrium condition for the number of firms. Okay, so that's what's going to happen at date 0. Now, the economy, of course, as it stands, is not competitive. We just have one investor, one consumer. So we want to make it competitive. This is going to be important for what's coming. So we replicate. So in the replica economy, there are our investors, like the single investor I described, and our consumers, like the single consumer I described. And it's easy to see that the equilibrium number of firms in the replica economy will be NR, where N is given by the previous equation. And of course, for large R, this is an approximately competitive economy. Now, one important thing here is that in the replica economy, in the basic economy, the single investor was holding in equilibrium 100% of each of the N firms. But in the replica economy, our assumption is going to be that each investor holds their pro rata share of each firm. So in fact, 1 over R, there are of them. So each investor will hold 1 over R of each firm. So they're going to be fully diversified. And if you want to have a story for why they would fully diversify, because after all, epsilon is an aggregate shock, well, we can always throw in some idiosyncratic components as well, and that would certainly explain diversification. Okay, so that's the basic economy. Now, that's when everybody thinks that pollution is not an issue in the world. But then at date 1, we suppose that it becomes apparent that pollution is an issue. And in particular, it becomes apparent that each of the NR firms, because replica economy, that has set up, each one is producing now harm using the technology that they were planning to use, which I'm going to call dirty. Each firm produces harm equal to H positive. Okay, and the assumption is this harm is spread equally over all agents in the economy, and there are 2 R of them because there are our investors and our consumers, and so each individual's utility is reduced by H over 2R by each dirty firm. Now, our assumption is that a firm can avoid this harm by incurring an additional fixed cost delta at date 1, and firms that decide to pay this cost are labeled clean. So that's going to be the thing we focus on, the choice, the decision whether to become clean. Now, benchmark, the obvious benchmark is the first best. So imagine a planner took over this economy at date 1. Now, the number of firms is fixed at that point. It's predetermined at date 0, so there's nothing you could do about that. But what the planner can decide is how many of those firms should adopt the clean technology at cost delta. Okay, in the paper, I'm not going to bore you with the details because it's all very straightforward. The planner is assumed to maximize investor surplus plus consumer surplus minus total pollution harm. And what you find is you get something very intuitive, which is that if H is bigger than delta, the planner is going to want all firms to be clean, to become clean. And if H is less than delta, she's going to want all firms to stay dirty. And that, it's very intuitive. For each firm, the damage of being dirty is H. You can remove that damage by incurring a cost delta. So it's natural that it should be a comparison between H and delta. And it turns out to be so. Okay, now we are interested in the case where there is no planner or government. They're out to lunch, and social action is left to individual investors or consumers. So remember, I'm going to be considering 3 strategies: divestment by investors, boycotts by consumers, or engagement with management. So let's start off with divestment. We're going to assume that a fraction pi of agents are SR, socially responsible, and the rest are purely selfish. And that's really true of investors and consumers. And an SR agent puts weight lambda on positive on those affected by their decisions, as well as weight 1 on their own payoff. You know, the rest are purely selfish. Okay, now let's start by assuming, so we've got, the only people who are going to divest are the socially responsible investors, okay, of whom there's a fraction pi. Remember, we're in the replica economy. And let's assume that some of them, maybe not all, some of them, a mass mu less than or equal to pi of these investors decide to divest. And we're going to see whether this is an equilibrium, given the impact they have. In other words, we're actually going to just check to see whether this is a Nash equilibrium. For a mass mu less than or equal to pi of the SR investors to divest. The way they divest is they make an announcement, which is visible, and they can commit to it. Now, this is actually quite a strong assumption, and I will come back to it. But for the moment, we assume that people know they're going to divest, and they can commit to do that. One other point, when I said that, you know, lambda's positive, it's less than 1. Less than or equal to 1. People are, you know, not more than 100% altruistic. Okay, now.
So Oliver?
Yes.
Perhaps before you move on, so there are a few questions. I got one, sorry Sandro to interrupt, but I got one by email.
Yeah.
So one question from Josef Spiegel is, so you assume that the harm is shared. So you have that each agent is going to bear H divided by 2R of the harm, right? So why not assume, as in the case of pollution, that everyone gets the full harm H, as we would think of a public good or a public bad?
Well, I don't think we do think of it that way. I think this is a public, it is a public bad, and its total cost for the economy is H. But it's not H for everybody. I mean, it's like national defense. I mean, or something like that. I mean, the total, but it's not like we all get the total. I don't think that's the right way to think of it. But if we did think of it that way, all resources should be spent on public goods, right? There would be no, because the, you know, you give up $1 to get 7 billion times H.
Mm-hmm.
It would be the wrong calculation, I think. To make this a sensible, H is the total. I mean, think of the benefits of clean air. Okay, what we want to do is I get a benefit, you get a benefit, and we add them up to get the total.
Right.
benefit.
That's why we have an externality.
That's what's going on here. So I want the total not to be infinity, as in the replica. You know, as R tends to infinity. It's the total stays constant.
Perfect. And I think
yeah, while we are at it, there is a question from the question and answer. Evgeny Zalubowski asked whether the values of H and delta are common knowledge since date 1.
At date
they
1,
are, right?
Yeah, this is an absolutely standard. There's no asymmetric information here at all. Everyone knows these things.
Okay.
Perfect.
Shall I keep going, or are there more?
Sure. Please go.
All right. So let me explain the divestment equilibrium works as follows. Some investors have announced they're not going to buy the shares of dirty firms. Okay. So of course this reduces the price of. We're at date 1, and the value was expected to be F of these firms, because nothing new was expected to happen. But now something has happened, and because some people are not going to buy the shares or are going to sell their shares at date 1, that's going to drive down the price of dirty firms. And that's going to mean that value maximizing managers, and we assume they are value maximizing, are going to find that it might be a good idea to become clean, because now there's a market for clean shares. These people who divested are willing to buy the shares of clean firms, and the dirty firms have become less valuable. So you can increase your value maybe by becoming clean and selling to this these divestors. So okay, so in an interior equilibrium, that's exactly what's happened. Some firms will choose to be clean and some will remain dirty. And let's look at the equilibrium. The values of the two must be the same in an interior equilibrium, because otherwise value maximizing managers would switch from one to the other. Now, in the product market, let's remind ourselves that when firms, or perhaps I haven't said it, actually, let me say it now. When a firm becomes clean, that doesn't change its supply decision because it's just a further fixed cost. And we're assuming the price is above that. You don't want to close down. So given that you're going to be operating and your capacity constraint is 1, you're going to still, we have an inelastic supply of N. Regardless of the mix of clean and dirty, which means the product market equilibrium isn't going to change. The market price will be the same as before, and so the expected profit stays the same, except for this additional fixed cost delta. Okay, so let me sketch out how we solve for the equilibrium. The demand for shares of clean firms, if the market value of all firms is V, then if you recall the formula previously, it was we took the expected profit minus the price of the shares divided by gamma sigma squared. So for the clean shares, the expected profit is now pi minus delta because they've incurred this additional cost to become clean. The price is V, so the numerator is pi minus delta minus V divided by gamma sigma squared. That's the demand for shares of clean firms. Now the mass of people demanding them is mu, so we have to multiply that by mu, and the supply will be NC, the number of clean firms. For dirty firms, the supply is ND, the number of dirty firms, and the demand is 1 minus mu times, well, the dirty firms don't have to pay the fixed cost delta, so for them it's pi minus V over gamma sigma squared. Okay. If you add those two equations, and remember NC plus ND equals N, which is predetermined, then you find that you get a formula, you can solve for V. It turns out V is F minus mu delta. So the result of divestment is to depress the equilibrium value of all firms. It goes below F, somewhere between F and F minus delta. More interesting to us is we can solve for the number of clean firms, NC, and it's given by that formula, and it turns out to be a quadratic. Now, if you look at that formula, you see certain things. First of all, this is assuming an interior solution, but NC doesn't have to be positive. If you look at the formula, it will be positive if mu is close to 1. If mu is 1, then you just get NC equals N, capital N. But if mu is close to 0, then in fact we might be at a corner solution. So that's what number 1 says there. If big N is less than delta over gamma sigma squared, then we're going to be at a corner solution in a neighborhood of mu equals 0. And this is a case of some interest, because what it means is that small levels, starting at mu equals 0, if you're thinking of divesting, it's going to have no effect at all if you're at a corner solution. So, okay, no impact. And that's going to happen, by the way. When is big N going to be less than delta over gamma sigma squared? Well, it's when gamma or sigma squared are small. In other words, let's take the gamma case. If investors are not very risk averse, then when I divest, all that happens is that Marina buys my shares with hardly any, sorry, I'm sorry, she's being here the nasty person. She's the purely selfish person. I'm the nice person. Sorry about that. And so she's willing, she's willing to hold the shares of dirty firms, and she doesn't really require any serious discount because her risk aversion is so low. On the other hand, if investors are very risk averse, then N will not be less than delta over gamma sigma squared, and we'll be at a corner, we'll be at an interior solution. In fact, that's what we're going to assume. Number 4 says that. For the rest of the talk, I'm going to assume we're not at a corner solution. Now, let me just also note number 3. Number 3 says that NC is less than mu n. So that is worth emphasizing. It says that the effect of divestment is less than proportional in terms of the impact on the number of clean firms. 10% of the investors divest, the number of the percentage of clean firms will be less than 10%, which is already suggesting that divestment is not as powerful as you might have hoped. Now, the next step is to decide whether this is a Nash equilibrium. Okay, we've assumed that a mass mu of investors divest, but is it individually rational for them to do so? So here we have to remember they're socially responsible, so they're going to look at the effect on them of divestment and the social impact, which they'll multiply by lambda, and then see whether it's a good idea to do it. Okay, well, I'm not going to go through all the gory details here, but let's suffice it to say that a divester, let's first of all talk about someone who doesn't divest. Someone who doesn't divest, they are now going to find that actually they're better off, because they can buy, they're only going to buy the shares, I should have said this, of the dirty firms. Should have said this a few minutes ago. Because remember, both firms sell at the same price, and the clean firms are less profitable because they have that additional fixed cost delta. So if you're selfish, you'll just be buying the shares of the dirty firms, which are now cheaper than you expected. You expected them to be selling at F, but they're selling at F minus mu delta. So this is all good news for you. And we can compute your certainty equivalent, and it's given at the bottom of the slide there. Now, the divestors are only buying the shares of the clean firms, which are less profitable. Their price is lower, it's F minus mu delta, but their profit has gone down by delta. So profit down by delta, price only by mu delta, where mu is less than 1. So the divestors are worse off, not surprisingly. It hurts you to divest. And what we can do is look at the difference, and the difference is given by the formula at the bottom of that slide. We don't have to worry about exactly what it says, but it's a positive number. Now, a socially responsible investor compares this personal loss with the effect on everybody else. Now, the effect on everybody else is composed of the impact on the environment from having fewer dirty firms if you divest, and the impact on other investors and on consumers. Well, consumers are very simple. You have no impact on them because, as I mentioned a few minutes ago, the product market is unaffected at date 2. The impact on other investors is also 0 to the first order, and the reason is it's the well-known envelope theorem. They're all maximizing. And so if I divest, that has a small impact on share price, but it has a second order effect on on the utilities of other investors who are maximizing. So that effect washes out, and we're left with the effect on the environment. Now, in order to compute that, let us note that we're in the replica economy, and the number of clean firms is currently NC, which I solve for, times R, because it's the replica economy. And right now, mu R investors are divesting, right? The mass mu and then times R for the replica. Okay, now suppose I'm one of those investors and I'm thinking of deviating from the Nash equilibrium, and I'm going to stop divesting. Well, if I do that, mu R becomes mu R minus 1. There's one fewer investor, which means mu changes from mu to mu minus 1 over R, you know, to dividing everything by R. In other words, delta mu is minus 1 over R. Now, the number of clean firms was NCR. It'll now be NC plus dNC by d mu times delta mu all times R. So the change is the second part of that. And think about what that is. dNC by d, look at the bottom. dNC by d mu times delta mu, well, delta mu is minus 1 over R, times R, so we just get minus dNC by d mu. That is the impact on the environment of my divestment. Now, okay, here I remind you the formula for NC. So obviously dNC by d mu, we can compute that, and minus dNC by d mu is just given by what I have there. All right, now, so that's the change in the number of clean firms. And every time you get one more clean firm, the environmental damage goes down by H. So we have to multiply minus this by H to get the impact on the rest of the world of your decision. And that's what I have at the top of the slide there. Multiply by H. And then the investor weights this by her prosocial parameter lambda. And remember, I'm assuming for simplicity that all the SR people have the same lambda. It's some positive number less than 1. Okay, so now here's our socially responsible investor. She will stay divested if the personal loss, that was the difference in the certainty equivalence, and I've just taken that formula and put it on the left-hand side there, if that is less than or equal to lambda times the effect on the environment. So this is the formula for her to be willing, to stick with the Nash equilibrium. Now we can rearrange that and we get the expression in star. Now, I can only have time to say one quick thing about this, which is, I think, a leading case. Think of the case where H is bigger than delta. So the planner would want all the firms to become clean. It is still quite likely that 2 lambda H is less than delta. If you think of lambda, how big is lambda? We should try to find out a bit more about this, but I wouldn't, lambda equals a quarter doesn't seem crazy even for, fairly decent people. So then 2 lambda is a half. And so H could be bigger than delta, but less than 2 delta. If that's the case, then 2 lambda H is less than delta. Well, in that case, if you look at the left-hand side in star, you'll see all the terms are negative. And therefore, star cannot hold because the right-hand side is positive. So that's another way of saying that people will not stay divested. So in that case, the only Nash equilibrium is mu equals 0, no divestment at all. It turns out things are quite subtle here, and it's not always the case that you're going to get too little divestment. You can actually get too much. You can sometimes find that people divesting even when H is less than delta, so you don't want any clean firms. But I want to focus on the case where H is bigger than delta and we don't get any divestment at all. Okay, let me move on to boycotting. Here I'm not going to go through the details. We don't have time. Let me just say the analysis is extremely, is very much the same. Because how do boycotts work? Some consumers, remember I'm assuming that a fraction pi of the consumers are also socially responsible. They have this parameter lambda positive. And some mass of them decide to boycott. What that means is they say, we're not going to buy the products of dirty firms. I mean, it's a homogeneous product, but we assume whether it's been produced by a dirty firm or a clean firm. So you're going to shun those products, which means, of course, that the dirty firms will find that the demand for their stuff has gone down and the price will go down and their profits will go down. And they may then find it's profitable to switch to clean because now there's a market, the boycotting people are willing to pay a higher price for clean stuff, and so they can make money from them. So in an interior equilibrium, value maximizing or profit maximizing firms will be indifferent between producing clean and dirty. And we can solve for that equilibrium in a very similar way that we did for the divestment equilibrium. And we get a similar looking formula there it is. It's a quadratic again, where instead of the gamma sigma squared, you now have tau, which was the slope of the demand curve. And again, you may have corner solutions, or you may not. And we can get a formula like star to determine whether it's a Nash equilibrium for a mass theta of the socially responsible consumers to boycott. That's the condition for a particular theta to be a Nash equilibrium. And it turns out, again, a crucial role is played by whether or not 2 lambda h is bigger or less than delta. So in a plausible case where h is bigger than delta, but 2 lambda h is less than delta, we get the same result, that the only equilibrium is theta equals 0. So I think the...
Oliver, we will be flexible given what will happen.
Oh, yeah, am I out? Okay.
You have about 10 minutes.
Well, I won't need that long, actually, because I'm going to say the engagement in words. There's a lot of... There are formulas there as well, but the intuition is extremely simple, but it's very important. I want to sketch it out. So let me just say that so far, I would say divestment and boycotting have not looked that promising if people are just measuring, doing it only to have an impact. We get these equilibria where, you know, the Nash equilibrium is nobody does it at all. Now, engagement is different. And unlike them, it's not institution free. So that's very important for what I'm saying, and provide some qualifications to what the conclusion I'm going to draw. But here I want to just look at something very simple. Imagine that the investors at date 1, who remember are fully diversified, could vote on whether their firms should become clean or dirty. Okay, well, okay, here are lots of formulae, but let's not bother about them. I'm going to say it in words. Here's the idea. Imagine you're asked to vote. Okay, let's suppose you're socially responsible. You have a lambda positive. So you think to yourself, if one firm, we're doing one firm at a time, if one firm becomes clean, its profit and value will go down by delta because it has this additional cost. Now, I hold 1/r of this firm. R is very large. I'm holding practically nothing. So there'll be a capital loss, but my personal capital loss will be almost 0. What about this? What about the rest of society? I also care about them. Here's where my lambda kicks in. Well, first of all, they're the rest of my fellow investors. They're all the other people invested in this firm. And they're going to lose delta because through the capital loss. Okay. But then there's the benefit to society of H. So I take H minus delta and I multiply it by lambda and I vote clean if that's positive and dirty if it's negative. Lo and behold, I act just like the social planner. If H is bigger than delta, I vote for the firm to become clean. And if H is less than delta, I vote for it to become dirty. That is actually, that's all what all the math leads to, but I think it's actually pretty obvious when you think about it. Now, so we get a rather striking result that engaging investors are actually going to do the right thing. And actually, it turns out to be true for all lambda positive. Doesn't matter how big your lambda is, even a little positive lambda should be enough. Now, of course, we are assuming, very important, dispersed ownership here. If you had large owners, they wouldn't do this because they would be putting a lot of weight on their own, you know, their personal capital loss, and that might, you know, get in the way of things. All right. I think because time is short, let me jump to the conclusions, which I think are pretty obvious that, I mean, if you buy the analysis, at least given the analysis, we actually, our main conclusion is that engagement looks like a potentially more positive force than divestment and boycotting. It can work better, it can push firms in the right direction, it can actually be more powerful, as long as you can get over the institutional constraints. That's a big if, and we have a lot of discussion in the paper of it. Let me just say 2 things and then I'll stop. First of all, in a way, we've actually favored, we've put, the playing field has been tilted in favor of divestment and boycotting, because we've assumed that people can commit to their strategies. In the simple model I've set out, this is not obvious, because suppose some people announce they're going to divest at date 1, when the harm becomes apparent, and then some firms become clean. What's to stop the divestors saying, aha, we've had a success, now we'll just buy any shares, we'll buy dirty as well as clean. Okay, that would be a problem, of course. If people saw that coming, they wouldn't bother to become clean. So we have to assume some commitment here, which we think makes sense for more visible investors, like Harvard University, say, but not so much for Oliver Hart. Anyway, we talk about that quite a bit in the paper. The other thing, of course, is we have not considered campaigns for divestment or boycotts, which might get people to do it even if it isn't a Nash equilibrium. Let me stop there.
Thank you very much. I'm going to exercise my privilege as chair and ask the first question before anybody else. So my question is the following. The conclusion that engagement is actually better than our strategies. Well, it's kind of trivial in your model in which all agents are the same. Therefore, they will vote.
I wouldn't call it trivial.
Yeah.
Okay, go on.
The conclusion will remain true if you add a distribution of benefits and costs, which is symmetric, so that the median voter will apply, and median equal mean, and then the median voter will vote exactly what's good for society. But
Good
that
question.
will no longer be true with asymmetric distribution, right? In particular, when the cost and the benefit are concentrated on small sectors of a population.
Okay, I mean, the short answer is we haven't considered it. I mean, you're talking about H being distributed in some fashion, are you?
And delta, possibly.
Well, delta is a cost for the firm, so I don't think that can be distributed.
That's right, but if you take into account that you're imposing cost on firms, that may affect your decision. But okay, let's talk about
a single cost for each firm, but the harm might, of course, be different. And yes, I mean, the answer is I don't know. I mean, it's certainly, I don't think we're suggesting this is a very general result, because of course, in reality, people can have different social goals about something. They definitely do. But I do think, I'm going to just again say, I don't think it's trivial that in the simple, that somehow, with the world diversification, that somehow the personal effect is dominated by the other effect. We didn't realize that until we sort of derived it. But I think the answer is it needs to be investigated. I think if the majority of people are reasonable, and you have a minority of people with weird preferences, it's not going to change things, clearly.
Right.
But that's basically all I think I can say at this point. To be investigated more.
Quick question. If I understood you right, the pollution came as a surprise. It was not anticipated at date 0.
Right.
What if it were? Would it change conclusions in your model?
Yes, that's we actually originally spent some time on, also looking at a rational expectations equilibrium, but we sort of we put that to one side. I think. So I would have to go back and look at my notes and think about that a bit more. I like this story personally because I think that at least as a first go. And it turned out, you know, we had our hands full with the analysis for this case, given all the different things we were looking at. You know, it's very natural, I think, that some of these things become salient midstream. So I think this is a leading case, but I agree that one should look at the other case, and we sort of have, but I can't. I'd have to remind myself of the conclusions.
Thank you.
May I report a few questions from the question and answer? So Eski Barizak says, this is related to the last point Oliver made, but with divestment and boycotting, there may also be social signaling or other related forces. Even if I don't care at all privately, I may care about how my friends perceive me. And both sorts of social forces may make these more effective. That's the question.
Yes, I don't disagree with that at all, but I think that one of the things this paper points to is that, I mean, people who do that, maybe they should also think about an alternative strategy. They can also signal things by engaging. For example, Harvard University made an announcement not long ago that it was divesting from, you know, oil companies and all this sort of thing, and attempting to become, you know, carbon neutral or whatever. You know, they didn't ask me, of course. If they had, I would have suggested actually that they perhaps should engage with management and try to persuade companies to become cleaner. I think that's another way to go. And you can, you know, if Harvard is trying to signal to people that it's a decent institution, it can signal it that way. Here we see, even if we don't worry about sustaining a Nash equilibrium. So even if we could pick mu, you know, that formula showed you got a less than proportional effect, you know, unless mu is 1 or something. So the problem is, I mean, divestment, even if you can get a bunch of people to do it and commit to it and stick with it, it's still the case that the rest of the market is going to buy up their shares, and that's going to limit their impact. And similarly, you know, if I don't buy dirty stuff, some other consumers will buy it, and that will mitigate the effect I have. And engagement doesn't have that problem.